Hi guys, good evening. Can you hear me? Hello. Can you hear me? Yeah. So let us start session. So yesterday class, just introduction, Java introduction given. Yes, yesterday class, yes, just introduction started. Yes, basics. Yesterday class about basics discussed here. Like, yes, introduction to software. So previous classes, yes, about your course information explained clearly. Yes, about your course information given here. Okay. Yes, about course information given. Next about Java overview discussed. Next, started just basics. Yesterday's class. Yes, what is software? Yes, in software, two categories like system software, application software. What is system software? What is application software? This thing discussed here. Next about bias discussed. Next about who is introduction discussed. Okay. Next application software, front end, back end discussed. Front end, back end discussed. Hello. Can you call back just class one? Yes, application software. Yes, this. Yes, about front end and back end discussed. Front end, back end discussed. Yes, what is Java exactly? Where using Java discussed. In front end languages and packages discussed differences. Yes, next language, low level language, high level languages. These basics yesterday. Generation of computers discussed here. Yes, about low level language, high level language discussed here. Low level language, next high level language discussed here. Okay, right? Yes, high level language to binary code. Today topic is yes, high level language to binary code. Okay, see here, languages. Yes, in software languages, first one, yes, low level languages. Second one, high level languages, low level and high level languages, and high level languages. So what is low level language? What is high level language? See, low level language, it's a system understandable language, right? Low level language, it is a system understandable language. It is a yes, it is a system understandable language. It's a system understandable language. Low level language, it's a system understandable language. See, it is in the form of binary code. It is in the form of binary codes. Binary codes means like zeros ones format. In the form of binary, it is in the form of binary codes. Okay, system understandable language. Yes, it is called as machine language. It is called as machine language. Next, high level language. Yes, it's like English language. High level language. Yes, it is like English language. High level language is like a English language. High level language is like English language. Looks like English language. One second. Yeah, someone is trying to join. Okay. Yeah. So high level language, it's like English language. See, high level language. See, these things like C program, C++, Java, Suppose C program, C program, C program. See, it's a C program, right? It's a high level language. Looking like English, it's a high level language. C program like a high level language. Okay. Yes, next. One more example, Java. Suppose Java. Yes. See, this sounds like English language. See, it's a high level language, right? Yes, English language. So they are high level language. They are high level C program, Java, and all the high level language. Okay. Yes, it's a user understandable language. Yes, it's a user understandable language. It's a user understandable language. User understandable language. It's like English language. High level language examples. Yes, C and C++. C and C++. Next Java. Yes, Python. These are all high level languages. Maybe HTML. Yes, all these are high level languages. High level languages. Okay. So these are low level languages. Yes, high level language. Low level language, machine language is system understandable language in the form of binary code. Next, high level language, they are high level languages. C program, Java, these all are high level languages. High level language. Java program, it's a high level language. But system don't know about this high level language. Yes, here it's high level language, right? System don't know about this high level language. Suppose C program, C program, C program, even C program also. Yes, looking like English. It's a high level language. C program. Yes, high level language, English language, looking like English language. C program looking like English language. Okay. Yes, next Java program also looking like English language. So these are high level languages, right? These are high level languages. C program, C++, Java, all these are high level languages. But system can't understand this language. Yes, system cannot understand your C program or Java program or Python scripting. System cannot understand it. System can't understand it. Okay. System can't understand. System cannot understand it. Okay. So system cannot understand it. System cannot understand all these languages. Okay. These languages, how to convert into binary codes. But these languages, okay, these languages, here these language how to convert it to binary code. High level language to binary code. The system understand language. Yes, high level languages to binary code. Binary code, high level language to binary code. Hello. See, high level language to binary code. High level language to binary code. Yes, which one will convert from high level language to binary code? Which one will convert from high level language to binary code? Yes. So high level language to binary code. High level language to binary code. Which one will convert from high level language to binary code? Yes, yesterday. This point discussed. Yes, interpreter or compiler. Yes, either interpreter or compiler. Interpreter. Yes, interpreter. Yes, interpreter or compiler. Interpreter or compiler converts. 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 Yes, converts. Converts from. Yes, from high level language to binary code. Okay, either interpreter or compiler. So interpreter or compiler, right? See, either interpreter or compiler. Either interpreter or compiler converts from high level language to, yes, binary code. High level language to binary code. High level language to binary code. High level language to binary code. Now, what is interpreter? What is compiler? Let us see. Interpreter, compiler. About interpreter and compiler. Topic is about interpreter and compiler. Yes, you must hear this now. To understand Java, first of all, what is interpreter? What is compiler? Before going to Java, let us see about what is interpreter, what is compiler. Yes, about interpreter and compiler here. Yes, let us see. So first of all, about interpreter, how interpreter is working. Let us see about interpreter here. Interpreter. Yes, interpreter. See interpreter. Yes, how interpreter is working here. First, let us see about interpreter. See, for this interpreter, I'm taking Python example. Python is the interpreter based language. Python is the interpreter based language. So, test that with some Python script. Yes, let us take some Python script. Python script. So, Python is the interpreter based language. Python is a interpreter based language. C language is a compiler based language. Okay, so Python interpreter based language. Let us see Python example. Let us see some Python example here. Let us see some Python example. Python. Let us write sample program Python script. Suppose mnref folder here. Let us write yes. So the empty mnref folder is empty. In this folder, just I am writing on Python script. Python to explain about interpreter, I'm using Python. For interpreter, I'm using Python. For compiler, I'll explain C language. Now Python, D drive mnref. So CMD command prompt. From this go to D drive means D colon that we take to D drive. So DER that D drive contents. Yes, DER CLS clear the screen. Yes, DER displaying contents of D drive. D drive contents. D drive contents. See mn.directory. Mn.drive is a directory. See D drive mn.folder, folder, right? D drive mn.folder. Folder. In D drive, yes, mn.directory. Directory folder both are same. Yes, in character interface a directory. Same thing GA folder. See D drive. mn.drive it's a folder. Here it's a folder. In GA folder, in character interface calling as directory. Now change the mn.directory. CD mn.row. Changing to mn.row. Change CLS screen clear. Okay, now dear mn.row folder, nothing empty. 0 files, 0 bytes. Nothing empty. Empty, right? Empty. Now let us try Python script. Let us try Python script. Let us try Python script. Yes, using Notepad, we can write simple script here. Yes, Notepad. I'm using Notepad. This is test.py Python script. Cannot find file. So do you want to create? 1 second. Cancel. Yes, space. Do you want to create file? Yes. Now here A is equal to 10. A very simple script. P is equal to 20. Yes, here script to add, subtract and multiply two numbers. C is equal to A plus B, adding two numbers. Okay, print. Okay, print. Yes, addition. Yes, addition is equal to comma. See, displaying C value. Next, C is equal to A minus B. Print. Yes, next subtraction. Subtraction is equal to C displaying C value. Next, C equal to A into B. Okay, yes, print. Yes, multiplication is equal to C displaying C value. See this. So A equal to 10, B equal to 20, C equal to A plus B. Adding. Okay. Yes. So A equal to 10, B equal to 20, C equal to A plus B. Okay. Yes. So A equal to 10, B equal to 20, C equal to A plus B. So adding, additional value C here. C equal to A minus B. Subtraction. So displaying C value. C equal to A into B. So multiplication, right? Yeah, this is simple script. Very simple script here. Okay. Save and exit. Now dir cls dir c test.py. Now the script running this Python interpreter. Python yes test.py. Yes. addition 30, subtraction minus 10, multiplication 200. Now here what is happening here? See this script running directly, Python interpreter, yes, running the script directly here. It is not checking for any errors and all that. Suppose C program, first of all, compilation, checking for all the errors. C program or C++, Java or .NET, you take any program. All these programs, first of all, checking for errors. First of all, checking for errors. But then if no errors, then execution. But here when come to Python here, directly script executing, no errors checking, nothing, no comparison process. Reason it's an interpreter. Interpreter, it won't check for errors, directly executing script here. Interpreter executes the script directly. Okay, that Python interpreter, Python interpreter. Yes, Python, it's a this interpreter. Yes, will run the script directly, running script directly. It won't check for any errors. See, interpreter initially it won't check for any error. Directly program executes. Interpreter will execute the script directly. It won't check for any errors. Interpreter never checking for errors here. Directly executing script. Directly executing. Okay. So interpreter executes the script directly. Executing script source code directly here. This is called source code. Source code, right? Source code. So interpreter executes the source code directly. This is called a source code. See, notepad. Yep, this is called a source code. This is source code. So interpreter executes the source code directly. It executes source code directly. It won't check for any errors. Interpreter never checking for errors. Directly executing script. Suppose now scenario. Suppose any error comes, what happens here? Suppose any error. See, I'm using up arrow key to get the previous comments. Up arrow key to get the previous comments. Up arrow key, history. Okay. Yes, up arrow key. Yes, notepad. Open this. Suppose, for example, here a mistake, comma missing. Suppose here bracket missing. Here double quotation missing. There are three mistakes. Then what happens here? So DR, CLS, DR. Now running. Yes, even errors are there directly running here. Okay, direct running. Yes, now showing error. Actually, totally three mistakes are there, three errors, but showing only one error. Actually, three errors are but showing only one error. So what is happening? How this interpreter is working? Let me explain about interpreter. Yes, how interpreter is working. Let us say about it. How interpreter is working. See, that Python script. First A equal to 10, first statement. Next second statement B equal to 20. C equal to A plus B. Next print addition. Okay, next C equal to A minus B statement. Print subtraction. Next C equal to A into B. Print multiplication. So these are interpreter statements, right? Yes, they are by scripting statements. These are scripting statements. They are scripting statements. So how interpreter working on script here? How interpreter working on this? Let us see. See, Python is a interpreter based language. Yes, how it's working? See, first the interpreter checking for the first line. So first line syntax is correct. Syntax means some rules like open bracket, close bracket, open double quote, close double, something like this. First statement is correct. Simply, yes, it converts. First statement is correct here. If first statement is correct, simply it converts into binary code. That codes, it converts into binary codes. Okay, zeros ones format. So interpreter checking for the first statement. Suppose first statement is correct. Simply converts into binary code. After binary code, this binary code given to processor. So processor taking this code, okay, and generating output. Okay, right? So interpreter checking for the first statement. If it is correct, converts into binary code. That binary code given to processor. So execute generating output here. Next, checking for next statement. Suppose next statement also correct. Same conversion binary codes and given to processor generating output. So what is happening here? First line checking, then executing. First line checking, then executing. 1 second. See here, first line checking, then executing. Second line checking, if it is correct, executes. Okay, next line checking. So it's a line by line. First line checking, if it is correct, finishing that is. Next line checking, if it is correct, finishing. Next line checking. Suppose something wrong here. Something wrong, simply stops. Yes. Something wrong, interpreter stops. If any error comes, interpreter stops. That means interpreter shows only one error. Actually, in the program here, totally 3 errors. In this program, totally 3 errors, but showing only one error. If any error comes, interpreter stops. See how interpreter is working. See, checking first statement, if it is correct, then generating output, executes. Checking next one, if it is correct, then executes. Next statement, something wrong, simply stops. Simply stops. Any error comes, simply stops. Yes, it won't check for next statement here. It won't check for next statements. If statement is correct, executes immediately. Next correct, executes immediately. Something wrong, simply stops. Simply stops. Here, same thing happened here. See, in this script here, see in this Python script, there are 3 errors. Here one mistake, here one mistake, here another mistake. Totally 3 mistakes. There are 3 errors. But what happens here? Checking first line, correct. Next line checking, correct. Next line checking, correct. Checking then execution, checking then execution, checking then execution. Here something wrong, here stop. Here stopped here. Script stopped here. Script stopped here. So it won't go for next statements here. So once error comes, simply stops. If any error, interpreter stops. Okay, any error comes, interpreter stops. See this. So first error. Dir, yes, Python test.py. Yes, see this. At line number 8 stopped here. So any error comes, simply stops. Now let us correct this mistake here. Yes, notepad. Let us correct this mistake here. Comma plus save. Control yes, save. Save and execute. That error. Yes, line number 8. That error. Correction is done. After that, now run it here again. Yes, now 12th line error. Now next error, right? Next error. That means the interpreter shows only one error, not all. Okay, now let us correct this 12th line error. So 12th line, so this is error. So this statement error. Save and exit. Okay, right? Yes. Now again submit next error. Multiplication. This statement does line number 16. Okay. So this one interpreter shows only one error. If any error comes, simply stops here. So any error stopped here. Here first time error here, stopping here. Stopped. So the error corrected. Next time error here, stopped. Next time error here, stopped here. That's it here. So any error comes, simply stops here. Simply stops. Right? Yes. See. Addition 30, subtraction minus 10, multiplication 200. Got it. So here how interpreter is working here. Interpreter checking line by line and executing. Interpreter checking line by line and executing. Yes, if any error comes, interpreter stops. Any error comes, interpreter stops. So interpreter shows only one error. Interpreter shows only one error. So this is about interpreter. Correct? Now let us see compiler. Yes, same thing if it is compiler. Let us take C program. For the compiler, let us take C program. How it's working. C program, compiler, C program, compiler. Okay. Yes, let us take some C program. Suppose test.c. C program. Yes, how it's working here. Suppose C program. Yes, let me open C. Yes, C program. Yes, it's opening. Yes, C program. Same example. Yes, main function int a equal to b equal 20 int c. C equal to A plus B. So addition C equal to A plus B. Addition C equal to A minus B. Subtraction C equal to A into B. Multiplication and all this. C program, first of all you have to compile it. See compile option. Enter key, compile success, no error, success, no run it. Yes, program executed. Program executed. Suppose any mistakes are there, then what happens? Let us see. Some mistakes. Suppose here semicolon missing by mistake. Here bracket missing, some mistake. Bracket missing. Okay. Suppose here some comma missing. Suppose here some semicolon missing. Some missing statements. Okay. Suppose here double quotation missing. Then what happens? Save. Now recompile. Compile it. See this. Errors. How many? Totally 7 errors here. So this is showing all your 7 errors. Press any key. See that. Look at the bottom. See 10th line error. Next 13th line error. 16th line. 18th line. Next 25th line. Next 28th line. Yes, 30th line. 32 line. Line number 32 like this. So top to bottom. Here this is showing all the 10th line, 13th line, all the errors from top to bottom. Yes, it shows all the errors from top to bottom. Okay. Yes, it shows all the errors from top to bottom. Yes, it shows all the errors from top to bottom. All the errors from top to bottom. Compiler. Yes, compiler. Compiler working is like this. Compiler checking for the first statement. Compiler checking first statement is correct. Even correct, it won't convert into binary code immediately. It won't convert, it won't execute immediately. It won't execute here. It won't convert, it won't execute here. It won't execute. Checking for next statement. Suppose next statement is correct. Even correct, it won't convert immediately. Then checking for next error. Next, suppose here it's error. Okay, error at some line. It shows that error at third line. Next, checking for next one. If it is correct. Checking for next one. If it is correct. Checking for next one. Suppose something wrong here. Error at some line. Error at some line. Okay, after that, next checking for next statement. Like this top to bottom. Compiler checks the all errors from top to bottom. Checks the all statements from top to bottom. Compiler checks all statements from top to bottom. Interpreter is line by line. Interpreter line by line. See interpreter checking first line, then executing. Next line checking, then executing. Any error comes, stops. Any error, interpret stops. But compiler is not like that here. Compiler checks whole program from top to bottom. Compiler checks whole program from top to bottom. Whole program from top to bottom and shows all the errors. So first error, next error, and next error. So compiler checks the all statements from top to bottom and shows all the errors in the program. All errors. Okay. Now let us correct all the mistakes here. See compile. Yes, errors, 7 errors total here. First error, next, this. All the errors. Okay, now let us correct all the mistakes here. Yes, now here semicolon missing. Here at the semicolon missing. Okay, now here bracket missing. Okay, yes, here comma missing, but I will not correct. What happens, we'll see here. Here semicolon missing, but I will not correct here. What happens, we'll see. Here double quotation missing. Double quotation missing. Okay, now saved. Yes, overwriting. Yes, compile. Yes, not 2 errors. Still 2 more errors. 2 errors. Press any key. 2 errors. See, 18th line, 26th line. These 2 errors. These 2 errors. These 2 errors here. So these 2 errors. So what is happening here? Comma missing. Here comma missing. Next what? Yes, semicolon missing. Now save it. Once program modified, it should save it. Saved. Yes, overwrite existing file. Overwrite. Say yes. After which, now compile. Yes. Success. Success, right? No errors. If no errors, what is next step here? Yes, compiler checks the whole code from top to bottom and shows all the errors from top to bottom. All errors from top to bottom. Okay, next we should correct the errors. Correction of all the errors. After correction, recompilation. When you recompile, next time no errors. Everything is fine. Next time no errors. Everything is fine. Everything is fine. Then what happens here? No error. See, compile, success message, no error. Then what happens here? If no error, compiler checks the whole program from top to bottom. Compiler checks whole program from top to bottom. Suppose if no errors, then it opens another file. It opens one more file. Here say test.c, right? Test.c. So this is your C source program. Okay, with this program. Next, it's open another file. After opening another file, this whole code converts into binary format. So that this code, this source code, that C program, this complete code converts into binary format and write to another file. Write into another file like zeros ones formats. Write into another file. Zeros ones. Write into another file. Writing to another file. That result, writing to another file. Okay, so compiler checks the whole code from top to bottom and writing to another file. If this file is called as exe file, test.exe file generates. Test.exe file generates. Exe. This exe file contains completely binary code system understand format here. So compiler checks the whole program from top to bottom. If no errors, generating one exe file. After generating exe file, like this exe file given to processor. Now processor taking that exe file and executing at a time. So at a time generating output. So generating output at a time. Okay. So exe file generates. Compiler checks the whole code from top to bottom. If no errors, everything is fine. Generating one exe file. That exe file given to processor. So processor generates output simply here. See, let me show that exe file also. See, this is program, right? What is name of the program? Some math.cpp. CPP and C language both are same. Both are compiler based. Both are same. Math.cpp. Yes, let us go to backend. C drive here. TC here. C software installed here. Bin here inside of this. That file. C math. Once let me delete old files. Delete and delete. Delete all the old files. See math.cpp. Yes. 2nd March 8:05 p.m. Just now it's modified. 2nd March 8:05 p.m. The date and time of modification this is. Edit. See this? A equal 10, B equal 20. See this. This is our C program. C program. Just now modified. C program just now modified here. 8:05 p.m. 2nd March. Now it's modified. Now, yes. Compile here. After compilation, now run it. When I try to run it here, something happens here. Try to observe it here. When I try to run it, now I'm running here. Run it. See this. See some file generated. Okay. 2nd March 88. Yes, at this time application means exe file. See, right click, check the properties, exe file, .exe extension, .exe. So math.exe file created. So math.cpp converted to exe file. Now this exe file executes. That exe file executing. Yes, exe file executed here. Exe file executed. Okay. Now run it here. Yes, exe file. Okay. Yes, again exe file created. See this exe file. Right? So behind of this exe file created then executed here. So this is working of compiler. So compiler checking whole program from top to bottom and shows all the errors. Compiler checks all the errors from top to bottom. If no errors, generating one exe file. That exe file given to processor. So processor taking that exe file and executing whole code at a time. So what is interpreter here? Only one line at a time executing. Checking first line, then execution. Checking next line, then execution. Checking next line, then execution. Suppose something wrong, stops. Right, so this is difference. Interpreter compiler difference here. Yes, you guys tell me. Yes, exactly what's the difference between interpreter compiler? Yes, what you understand. Yes, what's the difference between interpreter compiler? What do you understand here? Tell me, guys. What do you understand finally here? Interpreter compiler differences. What do you understand finally? Yes, interpreter versus compiler. Yes, interpreter versus compiler. What you understand finally? What you understand finally? Yes, interpreter. Yes, interpreter, compiler. Yes, what you understand finally? Can. Okay, Santosh. Interpreter checking line by line. Okay, fine. Yes, Nadia, interpreter line by line. Good. Next, any other difference? Any other difference? Here, there is a main difference here. Main difference. What's the main difference? Line by line and whole program. That's okay, fine. Main difference. What is observed here? See, in these two pages explanation here, two pages in these two pages, this page explanation and this page explanation. What you understand? Just observe these two pages. We'll see the difference. Yes, this page. See this page. Interpreter explanation and compiled explanation. What you observed in different in these two pages? Yeah, this box, right? This box. Yeah, Vishal, okay, good. Yes. Compiler converts whole thing into exe file. Interpreter is line by line conversion here. But in compiler, interpreter is line by, but compiler one exe file creates. This is main difference. Compiler generates exe file. Interpreter does not generate exe. Simply line by line conversion then execution. Yet the result won't write to any other file. The don't have another file. Directly script executes. Converting it to bind record then executing. Converting it to bind record then executing. No exe file here. But compiler generates exe file. Okay. See this here. Yes. Python scripting. Dir. See test.py. Test.py. So Python. Yes. Test.py script. Here direct executed. No exe file. No exe file. Exe file is not there, right? Direct executed. Direct executed. Direct executed. When come to compile here, what's happened here? Yes, it's created one exe file. That exe file executed. Exe file executed. Now let us see differences. Yes, interpreter versus compiler. Yes, interpreter. First difference. Yes, it checks the quotes. It checks the quotes. It checks the quotes line by line. It checks the code line by line. Yes, interpreter. Yes, it checks whole codes. It checks whole codes from top to bottom. From top to bottom. From top to bottom. It checks whole code from top to bottom. Right. Next, interpreter. It executes. It executes line by line. Yes, it executes codes line by line. Executes code line by line. Line by line. Yes. Next, compare whole program at a time. Yes, whole code at a time. Whole code because exe file. Whole code at a time. Whole code at a time. Whole code at a time. The interpreter checks line by line, but compile is top to bottom complete codes. Next output executing line by line, but compiler at a time because exe file. Next, see interpreter it shows only one error. It shows only one error. Only one error. Yes, compiler it shows all errors. It shows all errors. All the errors from top to bottom. All the errors from top to bottom. From top to bottom. From top to bottom. It shows all the errors from top to bottom. It shows all the errors. 1 second. Yes, interpreter. It shows only one error, but compiler it shows all errors from top to bottom. Next important point. Interpreter. Yes, it does not generate. It does not generate exe file. Compiler it generates exe file. Here is main difference. It generates exe file. It generates exe file. Next, one more difference here. See, interpreter executes the source code directly, but compiler what happens here? One exe file generating that exe file executes. Exe file executes. Okay, interpreter. See, it executes. It executes source code. It executes source code directly. It executes source code directly. It executes source code directly. Yes, compiler. It executes exe file. Okay, it generates exe file and executes exe file. It executes. It executes. It executes exe file. It executes exe file. Okay, it executes exe file. Okay, right? Yes, next here. See, interpreter based languages are called scripting language. These are called as scripting language. They're called as scripting languages. Scripting language. Compiler based language are called as programming language. So these are called as programming language. Programming language. Okay. So interpreter based language are scripting language. Compiler based programming language. Okay. See, interpreter based language, scripting language examples. Scripting language example. Best example what? Python, right? Python, just now discussed. Python is the interpreter based language. Python is interpreter based language. Any other languages? Python is interpreter based. Next, JavaScript. JavaScript also interpreter based language. JavaScript is not a Java. JavaScript is different. Java is different here. Java using at the server side. JavaScript is at the client side. JavaScript is different. Java different here. So JavaScript is different. See, JavaScript using at the browser. Java using at the server side. JavaScript with the browser client side. Java at the server side. Next, one more thing here. JavaScript is a browser understandable language. Java is a JVM understandable language. JavaScript at the front end using here. Java at the server side using. So JavaScript and Java both are not same. That is different. This is different here. JavaScript is a interpreter based language. Okay. So the browser is an interpreter for the JavaScript here. Browser is an interpreter. Okay. Yes, Python, JavaScript. Suppose PHP script. Yes, HTML scripting. HTML is also scripting language. HTML, hypertext markup language. Hypertext markup language. Browser is an interpreter for the HTML. Browser is an interpreter for the HTML. Next, PHP scripting. Yes, PHP is having its own PHP interpreter. Next, Perl scripting interpreter. Okay, next, Linux shell scripting. So these are interpreter based language. Compiler based examples here. Compiler based programming language. C and C++. Next, .NET, C#. Okay, so these are interpreter based languages. These are compiler based languages. Okay, yes. Finally, some conclusion. Interpreter compiler difference. Exe file. Main difference here, exe file. So interpreter based language. See, interpreter. Yes, interpreter based language. Interpreter based language. Yes, don't have exe files. Yes, don't have exe files. Here everything is an exe file. Everything is an exe file. Everything is an exe file. So finally generating exe file, then executing. Okay. Yes, simply finally here interpreter based language don't have exe file. Compiler based language, everything is an exe file. Fine. So this is difference here. Interpreter and compiler differences here. So interpreter based language examples, compiler based language examples here. Okay, fine. Now here some doubts. You guys are getting some doubts. Yes, MN Rao explaining about all of these things, but he's not talking about Java. You're definitely 100% getting this doubt, right? Yes, I'm talking about many things here, but not talking about Java. Now let us see Java. So Java, is it interpreter based or compiler based? Yes, here in these examples don't have Java. In these examples also don't have Java. Then what is Java? Yes, Java. Is it interpreter based or compiler based? Anyone idea about it? Yes, of course I'll explain. Yes, Santosh, Java is a compiler based. Next others. Anyone idea about it? What is Java? Is it interpreter based or compiler based? Is it interpreter based or compiler based here? Yes, Vishal. saying that both. Yes, Nadia saying that both. Okay, fine, well and good. Yes, Raju saying that both. Fine, well and good. First, let me explain. I will explain about the Java, how Java is working. Then finally we decide it here. I'll explain about Java, how Java working, way of working. I will explain. You decide it finally here. See, except Java, is in other languages. What happens here? Except Java in other languages, source code. Suppose this is source code. A C program, it's a source, this source code. What are the program we are writing? Our program is a source code. This source code simply converts into binary code. Source code converts into binary code. That binary code given to processor, then finally generating output. Okay, suppose if C program, compiler converts source code to binary code. Suppose Python scripting, then interpreter converts source code to binary code. So C++, compiler converts source code to binary code, then given to processor, finally generating outputs. So case of other language. Next in Java, what happens? Let us see in Java. What happens here? So in Java, first of all, source code converts into byte code. Source code converts into byte code. This byte code converts into binary codes. This binary code given to processor. So processor then finally generating outputs. Now what is happening here? In Java, it's happening two stages. First step, source to byte code. Next step, byte code to binary code. See, except Java, in other languages, source to binary code directly. Only one step. But here two steps. So you can byte code introduced in Java. So byte code. So why byte code introduced in Java here? Byte code. Some intermediate code, right? Intermediate codes between source code, binary code. This intermediate codes here. Why this intermediate code, byte code introduced here? See, byte code was introduced. Byte code was introduced to make Java as independent platform. Java as an independent platform. Independent of platform. Yes, we'll discuss that also. To make Java as independent of platform. Okay. Yes, purpose is to make Java as independent of platform. See here, byte code. Byte code was introduced to make Java as independent of platform. Okay. Yes, here Java source code to byte code. Yes, who will convert source code to byte code? Source code to byte code by the Java compiler. Okay, source code to byte code by the Java compiler. Okay, next. Yes, byte code to binary code. Next, byte code to binary code. So this is by the Java interpreter. Yes, let me show that practically. Source code to byte code by the Java compiler. Byte code to binary code by the Java interpreter. Yes, let us see Java also. CLS. So dir del star all the files deleting. Say yes, deleted. CLS clear the screen. Dir see 0 files. mnref folder. D drive. mnref folder. Yes, it's empty. Folder is empty. That mnref directory. Yes, empty. Now let us write Java program. Yes, notepad. Test.java. Yes, open new file, create new file. Yes, simple Java program. Public class some test. Yes, open brace, close brace. Class starting ending. Next main methods. Like a C program, Java some main method. Public static void main string yes caps string square brackets. Yes, starting main, ending main. Okay. Yes, instead of main. Yes, system dot. Yes, out dot. Println. Hello world. Okay. See, for understanding purpose, I'm using Notepad. For easy understanding purpose, I'm using Notepad. Actually, well, daily class is using Eclipse. Yes, everyday class. In your class, actual topic is using Eclipse. Suppose if you are writing code in Eclipse, may not be understanding at this stage, may not be understanding. Okay, Eclipse next tomorrow. Tomorrow we are going for Eclipse installation, Eclipse and Java installation tomorrow. Now, simply just using Notepad, just Notepad, use it here. Notepad for easy understanding. Public class test. So hello world program. Save and exit. Okay, DR. Test.java created. Test. Now we should compare Java C. Test.java. Test.java, right? Yes. Compare. Yes, one error. One error, right? This one error. Here, yes, ARGS missing. Save. Yes, 1 second. Suppose there are mistakes, for example. Three mistakes. Save and exit. Not DR, CLS, DR, yes, Java C, test.java. Yes, compile. Now all three errors. It's a compiler. Compiler, because of compiler showing all the errors. It's a compiler. It's a Java compiler checking all statements from top to bottom, showing all the total three errors. First one, next one, next one. Okay, so it's a compiler here. It's a Java compiler checking for all the errors and shows all the errors from top to bottom. It's a compiler. Okay, right? Yes, now, yes, the closing bracket. Next here, semicolon missing. Next here, closing brace. So these things are missing. Save and exit. Now let us recompile. Java C test.java. Yes, recompile. Yes, no errors. If no errors, yes, dot class file generated. Test.java 827 created. Test dot class file 8:28 PM, right? Dot class file generated. So what is happening here? Java. So first test.java, right? Test.java. So this is source code. Test.java is a source code. It's a source code. It's a source code, right? Yes, it's a source code. A source code given to Java compiler. Okay, we are checking for all the errors. No errors generated one dot class file. So what is dot class? This dot class file contains what? Bytecode. It's a bytecode. Dot class contains bytecode. Now test.java given to Java C Java compiler result is test dot class bytecode file generated. Dot class a bytecode file. Now executing Java test enter key. Yes, executed. Now what is this Java C means is a compiler. Java C means compiler. Java C means Java compiler. This Java means is the interpreter. Now program executed by the interpreter. So this program dot class file executed by the interpreter. Compilation errors checking by the compiler. Then program execution by the interpreter. Errors checking by the compiler. Program execution by the interpreter here. Not dot class file. So this dot class file given to Java interpreter, right? Dot class file is given to Java interpreter. So Java interpreter takes the bytecode file, dot class file. After taking, yes, converts into binary code. Format. So bytecode to binary code by the interpreter. See source code to bytecode by the compiler. Now, yes, that bytecode to binary code by the interpreter. After converting into binary code given to processor, finally generating output here. So what is happening here? Yes, in Java errors checking by the compiler. Errors checking by the compiler. Errors checking by the compiler. Yes, if no errors, yes, it generates dot class file. Right? It generates dot class file. If no errors, then it generates dot class file. Dot class, right? After generating dot class file here, the dot class program, see dot class dot class program. Dot class program execution by the interpreter. Execution by the interpreter. Execution by the interpreter. By the interpreter. Execution by the interpreter. So execution by the interpreter. Okay. So errors checking by the compiler, but program execution by the interpreter. Okay. Okay. So here errors checking by the compiler. If no errors, then program execution by the interpreter. Now tell me, what is Java? Is it compiler based or interpreter based? Now finally, now tell me here. As per this explanation, what is Java? Is it compiler based or interpreter based? Or is it both here? Is it compiler based or interpreter based, or is it both here? Tell me guys. As per my explanation, finally some conclusion. Okay. Okay. Yes, it's a both simply. It's a both here. It's here. There are two things involving compiler as well interpreter. Both are involving. Compiler as well interpreter. Compiler as well interpreter. Both are involving. Both are involving. Compiler, interpreter, both are involving. So both are involving. So Java depends on Java. Yes, Java. Yes, depends. Java depends on both compiler, compiler as well as interpreter. So Java depends on both the compiler as well as interpreter. Error checking by the compiler, but program execution by the interpreter. So Java depends on both the compiler as well interpreter. So that's the reason here is not showed examples. Java both. Yes, in Java both are involving compiler as well interpreter. Two things are involving. Java two things are involving. Java two things are involving here. Compiler as well interpreter. Two things are involving here. Okay, right? So Java depends on both the compiler as well interpreter. That's it here. This is conclusion about Java. Yes, now finally some question for yes. Some question. Yes, based on your understanding, some question for you guys. Can we create exe file in Java? Simple question. Can we create exe file in Java? Can we create exe file in Java? Yes. Can we create exe file in Java? Yes, Java is a combination of both. Yes, compile, interpret, that's okay, fine. Can we create exe file in Java? See here about Java explain, right? Dot Java file dot class. Yes, have we observed any .exe file in this process? Have we observed any .exe file in these steps here? Have we seen any exe file here? No exe file. Java don't have the concept of exe files. No. So here question is simple question. Can we create exe file in Java? No question of exe files in Java here. No. Okay. See Java, yes, Java don't have exe file concepts. Exe file concepts. Java don't have exe file concept. You can't generate it. So Java don't have exe file concept. So why exe file concept eliminate in Java? To make it Java as independent platform. Yes. To make Java as an independent of platform, independent of platform. To make the Java as independent of platform. Yes, exe file concept removed. Exe file concept. Yes, exe file concept removed from the Java. Removed from the Java. See exe file means that is platform dependent. exe file, wherever exe file concept is, that is platform dependent. Yeah, that also we'll discuss. Yes, how Java made us independent of platform, that also we'll discuss. Okay, so Java don't have the exe file concept here. Just to make Java as independent of platform, exe file concept was removed from Java here. Okay, see, exe file is different, dot class file different here. Java don't have exe file. In Java, everything is in Java. Yes, in Java. Yes, in Java, everything is a dot class file. Yes, it's a interview question. Can we create exe file in Java? No, no. Then why exe file concept removed in Java here? To make Java as independent of platform. Yes, exe file concept removed from Java to make the Java as independent of platform. Yes, same we'll discuss. Wait. Yes, in Java, everything is a dot class file. Dot class file. Okay, so dot class file is not exe file. Dot class file is not an exe file. Exe file is different. Dot class file is different here. Okay, so what is exe file? See, exe file is a binary code file. Exe file is a binary code file. It's a binary code file. Binary code file, and it's a system understandable language. System understandable language. Understandable language. System understandable language. Exe file is a system understandable language here. Okay. So what is dot class file? Dot class file is a bytecode file. Bytecode file. Dot class is a bytecode file, and it's a JVM understandable language. Bytecode is a JVM understandable language. See, exe file is a binary code. Directly it's a system understandable language. Alright. Dot class file is a bytecode file, and it's a JVM understandable language. Okay, next one more thing here. Exe file, yes, is an OS dependent, means platform dependent. Exe file is a platform dependent here. Platform dependent, OS dependent or platform dependent. But dot class file is independent of dot class file. See, dot class file is an independent of platform. 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 Okay. So this is about Java introduction. Java depends on both the compile as well interpreter. Error checking by the compiler, program execution by the interpreter. In Java, don't have the exe file concept. We can't create exe file in Java here. So exe file concept removed to make Java as independent of platform. Yes. So this is just introduction. All the basics. See what this is our document here. See, yesterday and today basics. Introduction to software, system software, application software. Next, about bias. Yesterday discussed here. About OS. Topic discussed. Next, front and back end discussed here. Yes, Java where using. Yesterday discussed here. Language and packages. Yes, low level language, high level languages. These concepts. Yes, today topic. Yes, interpreter compiler. Today topic. So all the points very clear prepared in document here. Get this document for you only. Yes, already shared. Get this document is software drive access given to most of the students. Yes, in your batch, yes, almost everyone paid except one or two guys. Everyone feels page, then share it to everyone. Yes, all the shared, document shared, JDK shared, Eclipse shared, next recordings also shared. Yeah, this is yes Java introduction. Same what we discussed today here. Same thing here it's there. Same prepared in document. So running notes is not necessary. You guys don't write any running notes, not necessary. Just you can follow this one here. Every point prepared in the document here. See, my class order and document order is both are same. Both are same. Yes, next about Java fields, independent platform. How Java made us independent platform? Most important topic this is. Tomorrow very interesting class. Tomorrow very interesting class. Don't miss tomorrow class. See, you guys may be joining to my batch or not, that is secondary, but don't miss tomorrow class. Don't miss tomorrow class. Okay, see the tomorrow class. Tomorrow class, yes, sir. Definitely We'll see very interesting class. Very interesting class. Okay. Very interesting. Yeah, that kind of class, that kind of explanation, no trainer will give you. Yes, that kind of class tomorrow I'll show you here. How Java made us independent platform. Okay, this practically I'll explain how it's a independent platform. Yes, exe file dot class file explains what is exe file, what is dot class file. Why exe file is ways dependent. Yes, next dot class file. How dot class file made us independent platform. The topic about exe file and dot class file. On exe file dot class file differences. How yes, exe file is how it's ways why exe file is ways dependent. Next, how dot class file made us independent platform. Okay. Yes, here exe file, some static linking and dynamic linking, all that concepts tomorrow we'll discuss. Tomorrow class, no doubt, is excellent class. It will be excellent class. Okay. Yes, try to attend. Don't miss it. Yes, you guys may be joining to my batch or not. That is secondary here, but don't miss tomorrow class. Okay. Yes. Any doubts, guys, for today? So this is just a Java introduction today. Yes. Next, one more thing here. Yes, in group. See group. This is your group. In group, last 3 classes shared here. Day 1, yes, day 2 and day 3. Today day 4. Day 1, day 2, nothing here. Okay, day 1, day 2, day nothing. Day 3, day 4. Today actually started. Today main topic started here. So this is WhatsApp group here. Okay. Yes, I'll give the WhatsApp number. I'll share you WhatsApp number. Yes, this is my WhatsApp number. Yes, share your information on this number. Yes, 8179 189 This is my WhatsApp number. On this number, share your name and Gmail ID. Okay. Yes, I'll add to group. Okay. Next, here sharing daily class in the group as well as drive access also. For your batch, drive access is there. Drive created, already drive created. Drive created. Okay. Yes, today for almost all guys, drive access given. Recordings access and next documents access and all that given here. Yes, still anywhere pending here, I'll give the access. Yes, take this number here, take this number. Yes, take this number and share this information. I'll add to group. 1 second. Yes, Java frameworks. Yeah, next month planning. Next month planning. Already at the end, some already one frameworks batch is going, but at the end, almost at the end finished. So next month, yes, March first week, sorry, April first week, we are planning a framework batch. That time I'll inform you. Definitely, I'll inform you. Within a 1 month, we are planning to start framework classes. I'll inform you. Now, just to take this information, take this number here, share the details. If anyone not in WhatsApp, share that information. I'll add to group. Okay. Next, one more thing, drive access. Yes, everyone drive access given already, except 1 or 2 guys. I think today 1 or 2 new guys are there. For the except that yes, almost everyone paid. I think in your batch 8 members were joined. 8 members paid fees. Yes, some members are absent today class. Okay, for all, yes, given access. Take this number. Yes, no worry. Yes, tomorrow you attend class. After that, take your own time. Yes, I'm not saying to pay fees immediately here. Take your own time. Okay, take your own time. No problem, no issue. Tomorrow see the class. Okay, take your own time. No problem. It's not urgent in paying fees. Take your own time. I'm not a commercial. Take your own time. No issue. Okay, yeah. So that's all for today. That's all. Okay. Yes, tomorrow about Java features and all that we'll discuss. After tomorrow we are going for Java installation also. I think installation class also will be there. Okay, yeah, that's all for today. So thank you guys. Thank you guys. Yes, have a great night. Have a great night. See you tomorrow.